Partition linked list. After reading this problem, you may seems like it is a hard problem because you have to divide the linked list into two parts. You have to do basically partition of a single linked list, but it is super easy. And this is my 16th lecture on linked list playlist. So if you are directly watching this video, I would recommend you to go watch from the very beginning. That will boost your confidence on a linked list. So let's deep dive into the problem statement. So you have given the head of a linked list and a value x, and you have to make a partition in such a way all the node that is less than x should comes before the greater greater than the value x. Okay. So it means if my x equals to 3 in example 1, all the node which is less than 3 should comes before it. So 1 should come before it, 2 should come before it, and again 2 should come before 3. And after that, all the node who is greater than should come after the 3, but they should maintain their relative positions. Like if 4, which is greater than 3, if it's before 3, then it should be before 3. If my 5 is after 3, then it should be after 3. Are you getting? They should maintain their relative positions. That's what it means. Let me explain you again the problem statement. Suppose if your k equals to 5, this node. So all the node which is greater than 5 should be after the 5 and they should maintain their relative position. If suppose there was a 7, so it should be come before 5. They should maintain their relative position, but it should come 7 should come 5, and all the nodes which is less than 5 should comes before the 5. So in this example, 1, 2, 4, 1, 2, 3, which are smaller than 5, they should come before 5. So that was the problem statement. After reading the problem statement, you feel like it's a hard problem, but that's not the case. So let's move to the solution. What we can think of. If I create two linked lists, which one will contain the smaller values and one will contain the larger value. After that, I can simply merge those two linked lists. Can I do it? I think. Let me say it again. I will make two linked lists, two different linked lists. Okay. One which will contain the smaller value than x, and the other linked list which will contain the larger value than x. After that, what I can simply merge them. I would simply say small can your next point to the large node, I mean large head. They can simply merge it, and after that you can simply return this small head. So let me try run it so you can understand it better. So what I will do, I will put my a curve pointer to the head initially, and I will start ever in a linked list. And the same for I will put my small pointer on the small head, and the large pointer on the large head, and every time I will check if my value of curve is smaller than my x or not. If it's smaller, I will say small next, can you point to this node? So my small next point to this node, and I will move my small. Okay. Then again I will move my curve. Then again I will check if this value is smaller than x or not. If this value is smaller, then I will say small, can your next point to this node? It will say okay. Then I will again move my curve and small. Then I will again check if this my x curve is smaller than my x or not. X is 5, k equals to 5. I have taken k equals to 5. So yeah, it is smaller. So move add into the small head. So you added it. Again, you check for one, it is smaller, so you add it into a small head, nothing to do. And after that, when my curve reaches to 5, you check if this value is smaller than my k or not. And is it not smaller because 5 is not smaller than 5. So you will add it to the large head. And if you add it into the large head, you will say large, can you next point to this node curve basically. After that, move your large. So you move your large, and my small will remain the same where it was previously. Then again you move your curve. Again check it is a smaller one, so add it to the small head. And again move your card and small. And again check for 3, it is a smaller. And again when my card reaches to 6, it is a greater one. So add it to the large. You will simply say large next, can you point to the card. After that, you will move your large and you will move your curve. After that, you have to simply merge it. So you can see small next. Can you point to the large next? I mean next of large head, because large head was here and its next pointed to 5. So you will see small next. Can you point to the next of large head? So small next. Can you point to the large? It's not large head. It will be the next of large head, because my large edge was a dummy node. So my next of small should be pointing to the next of large head. And at the same time, you have to say large next, can you point to null? And after that, you can simply return the next of large head. So that was the whole thing. My small head was here, so you can simply return the next of small head. And you can see a linked list here. Now let's try to code it up. So I have moved to the lead code. So what we need? We need couple of variables. So let me first create small node, small and large head, small head equals what? New list node, new list node. Let's give it a value 0. And the same for the large head. I need one more linked list called large head and make it new list node with 0. I will be writing C++. After that, I will write Java and Python. And after what we need? We need couple of pointers. So I need my small head. I mean small, which will pointing to the which one? Which will pointing to the small head. And same for the large. I need the large, which will point into the large head. And what we need? We need a curve. So let's create the node curve, which will point into the head. By the we didn't need the curve. We can simply traverse using the head, but it's the best practice. So not to change the head. So what do we need? While my curve not equals to null, so my simply write the curve. So my curve until it's not reaches the null, what I will do? I will compare if my curve val is smaller than x. If it's smaller, what I have to do? I will say small. Can you next point to the curve? After that, I will move my small. So my small move to its next, move to next, and same for the large. If in the else part, I will write the large. Can you next point to curve because it's greater and move the large. So my large moves to its next. After that, after if else, you can simply move your curve. So my curve moves to its next. And when this while loop got exhausted, after that you have to merge it. You got two different linked lists. Large head, you have to merge it. So what you will do? First you will say large. Can you next point to null? I don't think you have to because yeah, you have to do it. So it's point to the null. And what I will say, small, can you next point to large or small head? Large head. Large head next of large head. After that, we can simply return our next of small head next. So I think it should be working. Let's see. Yeah, it's working exactly fine. I will copy the whole thing and I will paste in the Java. Let's move to Java. In the Java, I will paste the whole same thing, but I won't be running it. I think you can do it. Remove the asterisk from everywhere. Okay, remove the asterisks, anything. And what put the condition here while my cur not equals to null, small null, and instead of those things, put dot. Change it accordingly. I think you can change, and it should be small null. I won't be changing because there's a couple of things you can change. I will directly moving to the Python. C plus and Java are almost same. So I'm moving to the Python. If I paste the whole thing here, what will happen? It will throw couple. So just remove it. I will write the code. I don't need list node. I need small head. Small head, which will be the new. It will not be new. It will be simply list node. List node with 0. And the same for the large head. Large head will be the same list node with 0. And we need couple of pointers. So my small, which will pointing to the head, not head. It will be pointing to the small head. And same for the large. It will be pointing to the large head. And after that, we have to traverse in a loop. So simply write header because I'm not creating a curve variable because it's not. I can simply traverse with the head using the head. So in this, what I have to do, I have to put the condition if my head if my head val is less than my x, what I will do, I will say small can your next point to what head, and I have to move my small, so small can you move to your next. Now everything will be same. So can I copy the whole thing from the C++? Let's see. If I copy the whole thing in the else part, till here, Control C, in the Python, Control V, just remove it. It will be colon. There's again couple of things to change. So okay, I have modified the whole code. So, but remember in the Java, no, sorry, in Python, it's not null, it's none. You can always see from next equals to none. Okay, so let me run it. It should be working because it's the same, exact same code, but the only change is syntax. So I don't think it should be matter that much. So what will be the time complexity? We are traversing the linked list, so big of n, and every time we're moving linearly one by one, so it will take a big of n, and every time we're putting a smaller node to the smaller head and a larger node to the larger head. Means we are only traversing once and we are doing all the operations, so time complexity will be big of n. Space complexity, are we using any extra space? No, we are not using any extra space. We are only using the space that is required. I mean, we have to give it a new linked list, so that's what we are giving it by creating a new linked list and returning it. So we are not using any extra space. So space complexity will be big of 1. So I hope you like this video. If you like, do subscribe, like, and comment below. I will provide the problem link into the description box so you can directly jump from there.